Okay, empirical formula calculations. These can normally get you quite a few marks in the exam for what is a relatively straightforward calculation. A lot easier compared to things like titration calculations or ideal gas law calculations where you really have to think about what's going on. For empirical formula calculations, you just need to kind of learn the process. So we've got glucose decomposing with some microorganisms to form a range of products. One of these is a carboxylic acid with an MR of 88. It contains 40.9% carbon, 4.5% hydrogen by mass. So again, let's highlight the information they've given you. 40.9% carbon, 4.5% hydrogen. And we're going to work out, because deduce just means work out, the empirical and molecular formulas of the carboxylic acid. First thing, which I'm hoping is jumping out to you right now, is percentages add up to 100. 40.9 plus 4.5 do not add up to 100, so something is missing. At this point, some of you might already know that a carboxylic acid, especially if you do biology, is a carbon double bond to an oxygen, single bonded to an OH, with something which we'll call R over here, but you don't need to care what R is. So that means you've got the carbon, you've got the hydrogen from the question, also contains oxygen. If you didn't know that, which you will do by the end of the course, but not necessarily yet, you should know from GCSE that glucose is going to be C6H12O6. There's the oxygen appearing again. So this mysterious other element must be oxygen. And they quite often do this with empirical formula calculations. They'll give you all but one of the elements and you need to work out what the other one is. So first thing we're going to work out is the percentage of oxygen, which is going to be 100, take away the 40.9, take away the 4.5, and you're going to end up with 54.6, I think, % of oxygen. Now we've got all the data we can possibly want, we can now make the table we always do with empirical formula calculations. So stick your elements as the headings, carbon, oxygen, hydrogen. Write down the percentages, so carbon 40.9, hydrogen 4.5, oxygen we've just worked out is 54.6. Then you want to divide it, so that's our percentage. Then you're going to divide it by the AR, 12, 1 and 16. These aren't overly complicated ones, and that gives you 3.41, 4.5, and this one's also 3.41. Next step, divide by the smallest, which in this case is going to be 3.41. So 3.41 divided by 3.41 is 1, same for the oxygen, and with the hydrogen it's going to be 1.32. Then you need to think, we need to make this into a full number ratio. So 1 and 1, they're both full numbers, so we don't care about that, whole numbers. The hydrogen, 1.32, that's not really close to 1, it's not close to 2, we can't round it. It is close to 1.33, so to get that to a whole number, let's times everything by 3, and that's going to give us 3, 4, and 3. So our empirical formula is going to be C3H4O3. So that's our empirical formula. Now we need to work out the molecular formula. To do that, work out the mass of the empirical. Can't spell. So that's going to be 3 times 12 plus 4 times 1. It's got 4 hydrogens plus 3 times 16. Add that all together and it equals 88. Now, normally at this point you do the MR from the question, this 88, and divide it by the MR from the empirical formula, which is also 88, and then times the empirical formula by that. But if we do that, we get the answer 1, and that's because the empirical formula is exactly the same as the molecular formula in this case. So because the MR of the empirical formula is the same as the MR of the molecular formula, the empirical formula and the molecular formula must be the same. So if we give ourselves marks for this, 1 mark for working out the mass of the oxygen, 1 mark for dividing all the percentages by the molar mass, 1 mark for getting the empirical formula and doing that times by 3, and 4th mark for working out the molecular formula is identical. That's empirical formulae and molecular formulae calculations.